Lucas for his statement.
Thank you, Chairwoman Johnson, for holding this hearing, and thank you all to all of our witnesses for coming to discuss this incredible discovery. Since Einstein predicted the existence of black holes, scientists have been able to observe their effects and refine theories on how they affect our universe. But this is the first time we've been able to see a black hole directly, and it marks a huge milestone in our understanding of the universe. We have this first ever image of a black hole thanks to pioneering collaboration between observatories around the world. To detect an image of a black hole, we needed a telescope as big as our entire planet. Not surprisingly, building that was out of the question. But every challenge presents an opportunity, and science funded by the National Science Foundation joined forces with astronomers, data scientists around the world to coordinate their observations, in effect, creating a global telescope. This is a great example of NSF's approach to basic research in driving scientific progress. And as Dr. Cordova told this committee just last week, NSF's 10 big ideas are about enabling research that crosses scientific disciplines to make big discoveries. NSF's coordinated and interdisciplinary approach has already produced 2 groundbreaking discoveries in its window on the universe. First, the detection of gravitational waves by LIGO, and now this image of a black hole. I want to put these achievements in perspective. When Einstein predicted the existence of gravitational waves, he also questioned whether these ripples in space-time could ever be observed on Earth. The signals are so small, traveling over such an enormous distance, that he doubted whether we would ever be able to create instruments sensitive enough to detect them. But now, 100 years later, technology funded by the NSF, developed over decades, makes it possible for us to confirm this fundamental prediction. That matters not only because it helps us understand the universe in which we live, it also because it contributed to the creation of other technologies that directly affect scientific progress, including semiconductors that our cell phones and computers use more powerful. The NSF's investments in ground-based astronomy have also given birth to technologies used in everything from airport security to LASIK eye surgery. But the scientists these projects have produced may be the greatest return on our investment. Hundreds of graduate students worked on this discovery, and their careers will be informed by this experience. And thousands of young students who watch this announcement may be inspired to pursue careers in STEM. These are whole generations of new discoveries that will contribute to scientific knowledge and American progress. We don't know yet all the ways in which the Event Horizon Telescope will broaden our knowledge of the universe or our technological development here on Earth, but it's certain this image is just the beginning of what's to come. I'm looking forward to learning more about this from our witnesses, what their discoveries teach us about the universe, what lessons we can take away from how to coordinate basic research in the U.S., and what's next for this project. Thank you for being here, and I yield back the balance of my time, Chair.
Thank you, Mr. Lucas. If